So in our scraper cycle, we talked about we had a load, we have a carry, we have a spread, we turn, we return, and then we turn again. And some of these times were fairly well described, right? Our carry time, we could look this up. Sorry, our load time, we could look this up. Our spread time is also the same. We can look that up. Turning, we were going to use 0.8 minutes. Sorry, 0.5 minutes, right? And our return and another turn at 0.5. And so we need to calculate what our haul and return time is, and we do that by laying out the distance between where we are loading and where we're spreading. And to give you an example of what it might look like, we load, we're going to go uphill 4%, then we're going to go, and we're going to do that for 500 feet, we're going to go level 1,000 feet, then we're going to go uphill 8% for another 2,000 feet. So this would be our total path that we're going. And when we're going up or down, up would be carrying load, down would be unloaded. And let's choose some particular equipment. I think we have data fairly handy for a 635E. Our road is poorly maintained earth. And it has a rolling resistance of 180 pounds per ton. All right, 180 pounds per ton. That's our rolling resistance. We need to look up our gross vehicle weight empty and our gross vehicle weight loaded. Right now, we're not going to worry about what the load is. We're going to assume that we're able to get the complete load put together. So that's an assumption, but in this case, it's not a particularly dangerous one. So we should be all right. And this is what we've been working up to now with our discussions, is to say this is where we're going. And I have lost track of my piece of my data sheet. Just give me a second here. Looks like that looks promising. So let's we've got to go and look up some data. So we do that. Let's go to a different different screen. I'm going to look up the things that we need to see. And take a little bit of time and see if we can't find our data sheets. Yeah, let's use we'll use this 637E, I'm sorry, 637E. And our gross vehicle weight empty is 112,320 pounds, and our gross vehicle weight loaded is 112,320 plus 75,000, which is 187,320. So I've entered those values here, 112,320, and then 187,320. From there, we need to go back to look at our rats. So I'm looking for my Caterpillar performance chart, and apparently it's not where I think it is. So bear with me for one more moment here, and we'll see where we go from there. So we've looked up our equipment. We have what we're going to use here as our brake, our retarder system, and we have our rim pull system. What we need to do, of course, is to go back and now convert this into a proper rolling resistance. So we need to this is going just great, isn't it? Okay, so we need to remember we had we had 500 feet at 4%. We had 1,000 feet at 0, and then we had 2,000 feet at 8%. We need to come up with our total resistance in each of these cases. So how are we going to do that? Well, we have section 1. Its length is 500 feet. Its grade resistance going up is +4. Section 2, its length is 1,000 feet. Its grade resistance going up is 0. And then section 3 is 2,000 feet long, and its grade resistance going up is 8%. Now we need our rolling resistance, which, if you remember, is equal to the rolling resistance in pounds per ton divided by 20. And we said that that value was equal to 180 pounds per ton. So here the rolling resistance is 9%, which is 180 divided by 20. Here it's 9%, and here it's 9%. And our total resistance in these cases is 13, 9, and 17% respectively. Once we have that, we would want to go back to our curve, where we would look up our performance. So keeping in mind that we're loaded when we're going up, we need to go to our performance curve. So we go to our performance curve with those three areas, those three data points, and we are driving, so we use our rim pull curve. We're going to assume that we have all the power that we need. We're loaded. We're going to come in here at the fully loaded weight. We come down here, and the first one we want to check is our 9% grade, which is there, right? So that's 9%. And that's where we have section number 2. We come across here now. We find out we're going to do that in 4th gear. And in section 2, we're going to be able to travel at 9 miles per hour. That is a 9% slope. In section 1, we have a 13% slope. We do the same thing, we come back, 13 is there. The 13 is going to let me, 13 is going to come over from here. And that 13% slope, we're going to be able to do that at 7 miles per hour. And then section 3, where our slope is 17%, We're going to come in here, move over this way to here, and we'll be able to do that at 4 miles an hour. So we'll do that at 4 miles per hour. So we can look up all of these values and see where we're going in terms of our velocity. Or speed, rather, more properly speed, right? So we have in here, I'm just going to clean up just a little bit. We have our total resistance at 13%, 9%, 17%, and this gives us our speed. And our speed in this section was 7 miles per hour. In this section was 9 miles per hour, and in this section was 4 miles per hour. And keep in mind that we know that the speed is equal to the distance over time, right? Miles per hour. So that means that the time is equal to speed distance divided by speed, and that 1 mile per hour is equal to 88 feet per minute. We know both of those, then we can go on from there and we can calculate where we're going. So if we're going in section 1, we're going 7 miles an hour. Section 2, we're going 9. Section 3, we're going 4. This is 500 feet, 1,000 feet, 2,000 feet. And so the time of travel is equal to 7 miles per hour. It's equal to 500 feet divided by 7 miles per hour times 88 feet per minute. And this comes out to tell us how long it's going to take to drive each particular section. So this is going to, actually I have to do the proper calculation more on. 500 over 7 over 88 is 0.81 minutes. 1,000 feet, 9 miles an hour and 88 feet per minute per mile per hour. That's going to take 1.26 minutes. And then number 4, 2,000 at 4 miles an hour, that's going to take 5.68 minutes. If we sum them up, this is our travel time loaded, which is 5.68 plus 1.26 plus 0.81, and that is equal to 7.75 minutes. So you can see how now we're applying the work that we had done looking at motive power to convert from the rolling resistance in terms of the preparation of the road versus and then comparing that to what happens when we are using a rolling resistance, converting that into an equivalent grade. Now we have to come back So this is our return. In the return, we use the retarder. So let's see what that means. We still have our three sections, number 1, number 2, and number 3. The length of the section, still the same, right? 500 feet, 1,000 feet, and 2,000 feet. Our grade resistance is different. Section 2 is still flat, so it's a 0. Now we have slopes. Now we have assisting slopes. Section 1 is -4, and section 3 is -8, because now we're going downhill. Our rolling resistance is still equal to 180 divided by 20 is +9, +9, +9, and our total resistance is 5, 9, and 1. You can see that even though we're going downhill, there's still a rolling resistance that's positive. This is different from what we would see or what we saw when we were going downhill. So now we have to use the retarder curve. The retarder is using back pressure from the engine to slow the vehicle and to keep its speed under control, so that we will get it going at a different speed. So we're going to try it this way, and this has been really quite crappy. Oh, there we go. Okay, so now we're going to try and look up our retarder values. So here's our retarder curve. We're going to come in at our loaded rate, our loaded weight, which is here for this particular piece of equipment. And you obviously would use the retarder curve for the proper equipment. The first one we want to look at is section 1, and section 1 was at 5% effective slope. So we come down to 5, where we hit where we hit 5 here. We come over. We're going to be able to use the retarder in 7th gear, and we're going to be able to do section 1 at a speed of 24 miles per hour. Can someone unmute their mic? Is that flickering for you?
Yeah, it is.
Yeah, it's flickering for me too.
All right, well, I can't hear anything, so we're going to go, we're going to do then section 2. Section 2 is section 2, the total resistance is equal to 9%. If I come down, here is the 9% curve. I hit the 9% curve, I come over straight, I hit 5th gear, and my retarder is going to give me a speed at 14 miles an hour. Section 3. Total resistance is equal to 1%. Same thing, we come down, we're going to hit 1%, we go over 1%, and we are going to be able to operate in 8th gear. And in 8th gear, we're able to go 31 miles an hour. You can see that we're below 7. There's nothing to go this way, so it means we can operate at the top end, just having it run full out. So section 3, our speed is equal to 31 miles per hour. Let's not come back to this flickering screen anymore. It's driving me crazy. I can't imagine how you guys are doing. Okay. So now we have our same sections, but we have our different speeds, right? So we have section number 1, 2, and 3. We have the distance of that section is 500 feet, 1,000 feet, 2,000 feet. We have different speeds now. This is our speed on return. Speed on return for section 1 was 24 miles per hour. Return on section 2 was 14 miles per hour. Return on section 3 is 31 miles per hour. And that's because we have a fair bit of grade assistance, right? This is going down an assisting slope, and this is going down an assisting slope. So the time, where the time is equal to the distance divided by the speed, this is equal to 500 divided by 24 times 88. This is 1,000 divided by 14 times 88. And this is 2,000 divided by 31 times 88. And this will give us our time as well. We have 500 over 24 times 88. This is 0.23 minutes. This is 0.81 minutes. And this is 0.73 minutes. And the total is 1.77 minutes. Now, the time out was 7.4 something minutes, I believe. right? 7.75. 7.75 minutes. And so now we have our entire cycle. So our total cycle, we just sum up all of our times, is equal to the load time, the up travel, spread, turn, a down travel, and another turn. So the load time, we can look that up in our table, is 0.8 minutes. Our up travel was 7.75 minutes. Our spread time, we're going to also take this as 0.8 minutes. It's based on experience. A turn is 0.5 minutes. Our downtime was a relatively small number, 1.77 minutes. And then another turn to maneuver and get ready to be loaded again. And so this gives us our total time that we can now add up. So that's 1.55, 2.35, 2.85, 2.92, 3.62, 4.12, and 12.12 minutes is our total cycle for one scraper. Now, we can figure out the number of scrapers that we need. That we're going to be able to do by saying that if this is our time for the complete cycle, if we divide that by our load time, so this is 12.12 minutes divided by 0.8 minutes is our load time, because they have to load at a particular point, we can now run through and figure out how many scrapers we're going to need. 12.12 divided by 0.8. And so our job is going to allow us 15.15 scrapers. It's what we're going to need so that we have a train of equipment going. And it also tells us what our production is going to be. So that's how we would calculate our scraper cycle and then use that to determine the number of scrapers. In our next installment, we're going to want to look and see how we translate this into productivity. But I'm nervous about a bunch of things. And so one of those things that I'm nervous about is how many of you are still actually following the class. We're not getting a great turnout, and that's fine. And so so that's what I've have tried to do is I want to stop here. I am not happy with the audio visual stuff again today. It was flickering awfully for me to the point I couldn't follow it. And a lot of what we've done this morning is sat there while I try to make the computer behave itself. So I'm going to put this on Canvas here within the next hour. I'm going to give you a couple of examples just like this for calculation for an assignment, and then I will see where things are going. Please turn in your assignments. The computer won't accept anything after midnight. You'll have to email it to me directly. Do you want to turn on your microphone if there's anything you need to say, or send me a text in chat? Or you all have my email address if you want to say something that they don't need everybody else to see. Is anybody still there?
Did you email our assignments to you?
Yeah, what up? No, what's going
Can you hear me?
Is that better? All right, well, we continue to have excitement. Oh, is there someone there?
So Kevin, is the assignment that's due tonight, is this what this is about, or is that about the previous stuff?
The previous one. You'll get an assignment here today that I'll set up for being due next Thursday. And what I think we're going to do on Tuesday is we're going to do the assignments, make sure that everyone's got a handle on that, and see where things are going. I guess to be